Okay, when you want to define constants in Java, so basically what a constant is you want the value to remain the same. Okay, so the value shouldn't change within the program, and that's what we call a constant. So in Java, you use a special kind of keyword, which is the final keyword. You write this in front of your variable definition, okay, and that becomes a constant. Okay, so if you look at here, you can see that double pi, the pi constant, is defined as a final double pi 3.14159. Month and year is defined in a constant with final, and Faraday constant is defined with a final in front. It's a short type, and it's 23060. So this part is what we call the named constant and the literal constant. This is the number part. Okay. Now if you want to display numerical values, you can use the print and println methods. Okay. So in the previous chapter, we learned the print method. Okay, system.out.print. So in here, if you have defined an integer number equal 15, you can print it out with system.out.print num, system.out.print by printing a string, then system.out.print the number itself. Okay, so print the num equals 15, this 10 is printed out directly. Okay, so you can use the system.out.print or system.out.println methods. Okay, so now the next thing is very interesting. It's about overloaded operators. So in our case, we learned the plus operator, which could have an overloaded meaning. Okay, so when we say overloaded, this means that basically it could have two different meanings. Okay, so the operator plus can actually mean two different operations, okay, depending on the context. So if you look at it, when you do a plus for value 1 and value 2, if both of these values are numbers, it becomes an addition, okay? And if either of them is a string, if you do string plus string, it becomes a concatenation. Okay, so when you're dealing with numbers, it becomes addition. When you're dealing with strings, the plus becomes a concatenation. Okay, so this makes it very interesting. When you use the same operator, we can actually define it in two different ways. Okay, and so if you look at this example with this evaluation tree, we want to do test plus 1 plus 2, and in this case you evaluate from left to right, and you can see that test plus 1 is a string concatenation. Okay, this is a string concatenation. So with this string concatenation, you become test 1. And then you have to do plus 2. Okay, so test 1 plus 2 becomes another string concatenation. So you have test 1, 2. Okay, so the first result is test 1, 2. Okay. Now if you look at the second one, if you evaluate 1 plus 2, okay, this plus is an addition. So the result becomes 3. Okay. So 1 plus 2 is 3. And after you calculated this 3, you add the test. So 3 plus test. In here, the plus is concatenation. It's a string concatenation. So the result becomes 3 tests. Okay, so you can see that these two different results are created. Okay, so sometimes the plus becomes addition, sometimes it becomes concatenation. Okay, so here it was addition, here it becomes concatenation. Here it's concatenation, here it's concatenation. Okay, now let's look at some sample code fragments with the constant final double pi. Okay, so here you can see that there's a final keyword in front with pi value equal 3.14159. The double type radius, area, and circumference. So here what we're trying to do is you have input radius and output the area and the circumference. Okay, so 면적하고 그 원의 그 전체의 길이를 구하는 거죠. 원 전체. Okay, so in the area, p times radius. Okay, pi r square, that becomes the area, 면적 구하는 거죠. And then the circumference, okay, 2 pi r, okay, then you get the circumference. Okay, okay, so once we get this area and circumference, we want to print it out, so we use the system.out.println, system.out.println. Okay, so given radius plus radius, area, circumference, we print out all these values. Okay. You can use a class called decimal format. So sometimes you want to format your decimal number. So this decimal format class provides you a way to format your decimal number. Okay, so here this example shows how you can use the decimal format object. So if I have this number 123.457893345, what I want to do is I want to have the number formatted with only 3 numbers under the dot. Okay, 0.000, something like that. Okay, so with this number, what I'm going to create is a new decimal format, and I will give this parameter argument, and then I'll name it df. Okay, so this is the decimal format object that I created, and inside this, with this decimal format object, I will call, first I want to print out the number, so the original number is this one. Okay, so this is the original number. Okay, and then I print out the formatted number. So when I format it out, I call df.format, then give this number. So when this is printed out, it will be printed out with 123.458. Okay, 123.458. So you can see that this is the number that is printed out from the df.format.num. Okay. Okay, now if you want to get some numerical input, you can use the scanner class again. Okay, so here's the scanner class. Now, when you use the scanner class, you always do the new scanner system.in, okay, which will create the scanner object. And here I'm going to have an age as integer, where I'm going to get the numerical input. So you print out a message, system.out.print, enter your age. And then what I'm going to do is I'm going to use the scanner to call scanner.nextInt. Okay, so here you call scanner.nextInt, and this nextInt will accept an integer and store it in the age variable. Okay, so if you call scanner.nextInt, you can store it into the age variable, which will read an integer input. Okay, what kind of inputs can I get from the scanner methods? You can get a byte. So if you call scanner.nextByte, you can get a byte. You can get a double, so you can call scanner.nextDouble. You can get a float, so if you call scanner.nextFloat, it will return a float. You can call nextInt, which will return an integer with nextInt. You can call nextLong, will return a long number. Okay, nextShort, you can call scanner.nextShort, which will return a short number. And then you can call scanner.next, which we did in the previous chapter, previous example. So string will be returned with scanner.next. Okay, so in the previous page we did scanner.nextInt, and the previous chapter we did scanner.next. Okay, so those were the examples that were previously shown. Okay, the math class is a very nice class because it has a lot of methods, nice methods that you can use. And the math class is included inside the java.lang package. Okay, so usually if you're using the java.lang package, you actually this is automatically important, so you know you can kind of just immediately use the math class. So in this example, what you can see is there's a double num xy, and xy is initialized. And then what I'm trying to do is I want to do a maximum operator. Okay, so I want to calculate max x and y. What is the maximum of x and y? So I call math.max x comma y, and then I add 12.4. Okay, and on this value I want to do a square root. Okay, so if you look at this part, there's a math.square root. So you calculate a maximum using math.max, and on this value you can do a square root. It's math.square root. Okay, so it will look something like this. This is math.square root, and then you have a maximum for x and y, and then you have 12.4. Okay, so this is this part, and the square root is this part. Okay, math class has a lot of nice methods. You can do a exponential natural number e raised to the power of a. Okay, e to the power of a, like this. You can do a log a. You can do a floor. You can do a maximum of a and b. You can do a power of a comma b, so the number of a raised to the power of b, so it's a raised to the power of b. You can do a square root a, okay, and you can do a sine a, okay, square root a and then sine a, okay. So there's a lot of nice kind of methods inside the math class, and you should remember you can just call math.exp, math.log, math.floor, blah blah blah. Okay. So the thing is, when you use the math class methods, you actually don't create any objects. So that's really kind of strange, because previously when you want to use something, you always do a new class and then blah blah, you create the object. But here you do not create the object, you just directly use the class name. So we'll learn about that. Why is that possible when you learn about static kind of things, okay, the static keyword. So right now you can just memorize that. Oh, for the math class, you just use the class name and then you give the method name. Okay, math.exp, math.log, math.floor, math.max, math.pow, blah blah blah. Okay. So computing the height of a pole, this is another example using the math class. So here what you want to do is you call math.ch3 on the alpha. Okay, so from the alpha value you want to convert it to radians, okay, and from the beta value you want to convert it to beta, okay, because when you use the sine alpha and sine beta, these alpha and beta should be radians, okay, radian values. So you convert alpha to alpha radian, beta to beta radian, okay. And then this part is encoded like this, okay. Oh, this part, okay, and this part is the top part, okay. So distance times math.sine alpha radian times math.sine beta radian. So that's sine alpha, sine beta, sine alpha and sine beta. And then you divide it by this root, okay. You have math.square root, and then inside you have sine alpha over beta, sine alpha minus beta, okay. So here you do math.sine alpha rad plus beta rad, math.sine alpha rad minus beta rad. Okay, so this whole thing is this one encoded, and you put it to the height value. Okay. Now, if you want to create random numbers, Java also provides some nice ways to create random number generation. You can use the random class inside the java.util package. Okay, so you can use java.util.random. Now, when you want to use this random class, you have to create an object here. So random equal random equal random. Okay, and so you do a random.nextInt like this. Okay, so on this object, if you call nextInt 11, 11 will return a random number between 0 and 10. Okay, so remember that you have 11, and that will return a number between 0 and 10. Okay, so you want to make sure that if you want to return number between 0 and 11, you should say nextInt 12. Okay, so the random will provide a number between 0 to n minus 1. Okay, if you call nextInt it'll provide a random number between 0 and n minus 1, inclusive. Okay, if you want to provide a number, random number between min and max, you can do a little bit tricky things. Okay, you call random.nextInt, and instead of 11, you give max minus min plus 1. And then, at the end, you can do plus min. Okay? So, with this, with the random number, you'll get a random number starting from the range 0. But then if you add min, that becomes min to max. Okay? Another way to create random number generation is you use the math class. So in the math class there is a method called math.random, and the difference is it will create a number between 0.0 to 1.0. And so if you want to create a number between like min and max, you have to do some tricks. Okay, this start with 0 to less than 1. Okay? So the trick we will do is, if you want to do something like between min and max, you will get the x number and then multiply with max minus min plus 1. Multiply with that, get the floor, and then you plus the min. Okay, so that it becomes the smallest number becomes min. Okay, so if we encode this in program, you get math.floor, math.random. Okay, you call math.random. This is the x. Okay, this is this part, and then you multiply with max minus min plus 1, and then you add the min. Okay, that will create a random number between min and max. Okay, so the return number will be your random number. Okay, so we've looked at two ways to create random numbers. One with the java.util random class, and then one with the math.random method. Okay. Now let's look at some dates. Okay, so one of the nice classes provided for dates processing is the Gregorian calendar class. The Gregorian calendar class could be used like this. You define Gregorian calendar, today and Independence Day. You declare those two names, and then let's say I created a Gregorian calendar object and give it to today, and another Gregorian calendar object is created, but this time I will give some date information. Okay, 1776 6/4 July, okay, July 4th. Okay, so 6 means July, okay, because 0 is January. So you create these two Gregorian calendar objects and assign it to Independence Day. Okay, so we've got today and Independence Day. Now when you don't give any parameters, it will be assigned today, the date of today. This one we want to initialize to some date, so it will be initialized to that date, and we call it Independence Day, that is today. Okay, so once you initialize these Gregorian calendar dates, sometimes you want to take out some information from the dates. So when you're using these date kind of things, you'll work with a lot of constants. Okay, so these are some constants you'll be working with. like year constant or month constant, date constant, day of month, day of year, day of month, day of week, the week of the year, what's the week of the month, and AM, PM, hour, hour of the day, the minute. Okay, these are a lot of constants that you will use when you work with dates. So let's see how these constants can be used. So one way to do it, use those constants is, let's say you've created a Gregorian calendar object for today. Okay, so the calendar equal new Gregorian calendar, and you print out system.out.print today is calendar.get. Okay, this from this calendar object you'll call cal.get, and what are you providing? Calendar.month and +1. Okay, so this calendar.month is going to be your constant. Okay, you can also call calendar.get, and calendar.date is going to be your constant. So when you're using these constants, the calendar is appended in front. Okay, so you have in the calendar class there is a month constant. In the calendar class there is a date constant. Okay, and you can also call calendar.get and give the constant calendar.year constant. Okay, calendar.month +1, calendar.date, calendar.year. Okay, so from this calendar date you can take out each of the components. So when you print out this whole thing, it says today is the month is 12 slash the date 18th, and then slash, okay, you have slash, and then the year 2008. Okay, so when you want to get some information about the date objects, you can use these kind of special constants. Okay, so we finished with most of the contents in chapter 3, and there's some problem statement to kind of do some sample programming. Okay, so also the homeworks are coming up, so you might want to make yourselves comfortable with all these classes. Okay, so try to kind of run each of these samples, and it would be very nice for you to fully understand each of them.